There it is. Good. And let's see here. I think we have any people waiting to get in. No, I think we're in good shape. So without any further ado, good morning or afternoon, everyone. Welcome to the March call. I'm Drew Dackworth, National Geospatial Programs User Engagement Group, and I'll be assisting with the call today. Alex Jonasy with NGP Topographic Data Services Group is usually on the call, but he's out on leave. And however, though, he will be able to help and assist later on with recording, which will help us get that out there in a reasonable amount of time soon. In a few moments, we'll go ahead with today's topic on the latest updates to the HydroAdd tool presented by Michael Tinker. And before we get going, though, I want to point out that the community calls are held on behalf of the USGS hydrography program, and so our hydrography program leads receive HL, Subuto, Sylvia Terziati, and so we often open up the call with any comments or reserve a moment or two for any comments from the leads if you had anything you wanted to share. I know a couple of y'all are here. Just want to check, Steve or Sue and Sylvia, I don't know if you're here. Any comments or anything we want to cover?
No, I think I'm good here, Drew. Thank you.
Okay, you're very welcome. And speaking of comments, we will have time after the presentation and the questions or any further comments from the leads or anyone else on the call. Okay, so I think we're ready to begin. So I'm going to go ahead and restate that our topic today is the latest update to the HydroAdd tool. Michael Tinker with the U.S. Geological Survey National Geospatial Technical Operations Center is our presenter. And Michael, I think we can go ahead and take it away. If you prefer, we would cover questions after your talk presentation. Is that your preference?
Yeah.
Okay. All right.
Sounds good.
Thank you, Michael. And I think we're ready to go.
Thank you, Drew. My name is Mike Tinker. I work for the U.S. Geological Survey, National Geospatial Technical Operations Center, NGTOC. We make the national map. That's the U.S. topo maps. I work in hydro partner support. This presentation is about hydrographic addressing to the NHD, and in particular, our web-based addressing tool, HydroAdd. HydroAdd allows you in a web interface to address your data to the NHD, that is to say, make the features in your data coincident to the NHD. In other words, to snap your data onto the underlying NHD features, and in the process conflate or spatially join some of the attributes of the NHD features to your data. Addressing your data allows you to track your own geospatial assets in relation to the NHD. Address data allows for some special kinds of geospatial analyses. In this presentation, I'm going to show you a couple simple use cases of address data, and then I'm going to do a live demo of the HydroAdd tool. First, we need to get into the weeds just a little bit. I know for a lot of you on the call, addressing is old hat, and you've seen some of these slides before, but I need to define hydrographic addressing for the newbies, so bear with me, we'll get to the demo soon. First, a stretch of river in the NHD is called reach. A reach in the NHD has a unique 14-digit code, the reach code. Second, a stretch of river have measures. 0 is downstream, 100 is upstream. No matter how short or how long, it's always going to have 100 measures. I think of it as a percentage upstream. Now that you have a reach code and a measure for every single reach in the NHD, you have a network addressing system. You can describe any point in the NHD uniquely with the reach code and measure. Now, you could always use a geographic address, such as a latitude or a longitude, but when you're doing hydrographic addressing, it's very useful to have a network address. For example, this USGS stream gauge sits at this reach code ending in 0421 and measure 19.8. It's easy to understand. It's easy to describe. One of the main benefits of a network address is that it allows you to resynchronize your address data when the hydrography is updated. It also allows for migration of data addressed to earlier versions of the NHD, such as the 1 to 100,000 scale NHD Plus. HydroAdd batch QC uses the reach code and the genus name. So if you have the reach code or genus name in your data from previous addressing projects, HydroAdd will honor those. If there are NHD features with matching reach codes or name in your search tolerance, we'll get to that in the batch QC demo. There are other terms that you hear for addressing, such as linear referencing, indexing, linking. These all mean the same thing. The term event describes the actual address data. Event is an old linear referencing term, and there's a bit of baggage associated with this term, but it's still very widely used in hydrography. It's in point. USGS has point events packaged in the NHD itself. We have nearly 300,000 events. We've already done the work of addressing for you 150,000 stream gauges, 60,000 dams, approximately 2,000 watershed hydrologic unit outlets or pour points. Okay, so let's talk about some use cases. Address data allows modeling and analyses. In this map, the width of the flow line depends on its flow in cubic feet per second. This model is possible because we have addressed USGS stream gauges. Many of these stream gauges have many decades of flow and velocity. They also have associated upstream drainage areas. So we can use fancy regression equations to calculate flow and velocity on ungauged streams. In fact, we've modeled flow and velocity for every single flow line in the NHD Plus high res. That's a powerful set of attributes. With flow and velocity built in to the NHD Plus high res, you can do many kinds of modeling analysis, such as time of travel studies for point source pollutants, or really cool maps like this. Address data is useful for tracking assets. The National Wild and Scenic Rivers was created by Congress in '68 to preserve certain rivers with outstanding natural, cultural, or recreational values and free-flowing condition. So obviously, wild and scenic rivers are national assets. The USGS, puts wild and scenic rivers on the US Topo. This little section of the US Topo shows Yukon-Charlie Rivers National Preserve. These are wild and scenic rivers you see highlighted in the map on the left-hand side. So as you can see, address data doesn't have to be points, it can be lines too. Every one of these address lines has a start point and an end point with reach code and measure, and the intervening geometry is coincident with the underlying NHD. Address data is useful for reporting. Section 303D of the 1972 Clean Water Act requires states to identify waters where current pollution control techniques cannot meet water quality standards set for that water body. Every 2 years, every state's required to submit a list of impaired waters to the EPA for approval. States must establish TMDLs for the pollutants on the EPA's list. And this little map shows 303D listed streams in Central California. Same deal, every stream on here has start reach code measure, end reach code measure, and the intervening geometry is aligned with the underlying NHD reaches. So the last point I'd like to make is that you can address anything to the NHD. Point source pollution, biologic sampling, invasive species. You can address pretty much any kind of hydro observation to the NHD. So the question then becomes, what do you need and how can we help? Which brings me full circle to HydroAdd. Before we get into the demo, I thought we would talk about some of the benefits of HydroAdd. Because it's a web-based tool, project collaboration is easy. Hold on, let me get my notes here. Project collaboration is easy. You can divide labor by hydrologic unit. You can select features in your service data by hydrologic unit. Teams can work together. They can collaborate together on a seamless WBD NHD. You've always got the most up-to-date data, no more downloads. The simplicity of HydroAdd is its web-based UI. This allows for easy rollout of upgrades, development of tools with multiple web technologies. ArcGIS Online as a host allows easy creation of web feature services, like really easy, permission-based sharing, seamless integration with ArcGIS Pro. Although we have benefits of a web-based tool, some of these same benefits can become limitations in a web environment. HydroAdd as an addressing engine. The API is a serial processor. So some of the limitations of HydroAdd is that batch QC can take a while. Individual batch QCs are queued up. So web-based tools are inherently slower. Benefits can become a liability in it sometimes if it's slow. If the response is not immediate during manual editing, the user has to wait for one batch QC job to finish. If the user kicks off a batch job and sees the % completed, just stay at 0. It can cause you all kinds of anxiety. So jobs are queued. Workarounds for large batch jobs are not totally ideal. Sometimes you have to break your batch QC jobs if they're too big into smaller pieces. Line events with very many vertices don't always behave. They don't always save. Too many vertices can just too much data over the network at once, and something just ends up timing out somewhere, and saving doesn't always work. Sometimes you have to try multiple times. Sometimes line events with very many vertices can freeze up batch QC. USGS web applications are protected by USGS Enterprise Security Application Services, ESAS we call. And in the case of HydroAdd, feature geometry is translated from ArcGIS Online host to the API as a JSON payload. And some of these URLs can be very long because you're essentially sending the vertices as a JSON in the URL, and really long URLs can be blocked by ESAS. So the user has to sometimes dice long lines into short lines with fewer vertices. And then finally, ArcGIS Online as a host is not free. And it takes time to publish your results to ArcGIS Online. I'll show you that in the demo today. We purposely throttle the number of features per second we send to AGOL during publishing. We don't want AGOL to think that they're being hit with a distributed denial of service attack and block the HydroAdd application. USGS is always playing catch up to Esri updates. Esri sometimes changes things at AGOL that can break HydroAdd. AGOL has an early adopter program for advanced testing, but they don't always give adequate notice, and sometimes they don't respond quickly to my queries. So I want you to be aware of the limitations. Now, these are not as horrible as they look on paper. And we can talk about the benefits and the limitations after the demo. So let's get into a demo. Okay. So here's a super fast tour of the user interface. What you're seeing is a selection by hydrologic unit. Up and then this is Puget Sound. I've selected these features here. This is wild and scenic rivers that I've selected. I've selected by HUC 1711-0008. I've also selected this Stillaguamish River here is highlighted, and so there is essentially an attribute table viewer, the information button here, so you can see the attributes of any of the NHD features and any of the features in ArcGIS Online, any of your services. So speaking of services, here are the services that I've stacked up. These live at ArcGIS Online. I've got a bunch of them here. They also show over here in your services. Actually, I'm going to close the identifier tool so I can expand my services. These services here, you can control individual visibility, and this is the same services over here on the left-hand pane. To show you how these all live up in ArcGIS Online, this is where you host your data. So all your data lives in a group at ArcGIS Online. I have a ton of groups, and each one of these groups has several different maps that you just upload from our ArcPro. That's how easy it is to make a service. You just upload it or you share it from ArcGIS Pro, and you got yourself a service. It's that easy. So here's some maps that I uploaded. The symbology is exactly the same as I created them in Arc Pro. So here's one 303D waters. I just downloaded these from the EPA Waters website and put them into the HydroAdd schema. So how about we get these lines here? So once I've drilled down, there's the URL, there's the live service. I'm going to copy that. Now that it's copied, I'll go back over to HydroAdd and add this service to HydroAdd. Paste in the URL I just copied, call it what it is. And there it is. And so if it just appears instantly. So if I zoom out, you'll see that this is a pretty dense service. A lot of lines here. The other services I have stacked up here today are, I've got the lines, the 303D lines. I've got some dams from Washington State. I've got some culvert data from the North Atlantic Aquatic Connectivity Collaboration. That's what that means. North Atlantic Aquatic Connectivity Collaboration. Culverts. I've got hydrologic units, pour points, and then I got a couple test layers here. So why don't we show how you can do a batch QC on some lines. I'm gonna actually turn off some of these layers because it's getting a bit busy. I'll turn off these dams. So you can see, just to even make it more clear, let's change our background. I've got a ton of different backgrounds. When you're doing addressing and you're in the business of addressing, it really helps to have as many background services as possible. So I'll just throw the hillshade on. We'll go back to US Topo in a little bit. And I've got, let's turn off some of these dots too. Okay, so HydroAdd is a queue-based editing system. That's the real benefit, is that you have queues. You can build queues with the surfaces or with the features that you want to QC. So I built a queue of wild and scenic rivers down in Beaumont, Texas. Let's go with US Topo. Let's do a quick refresh here. There we go. There's our queue. I've got 6 features in here. You'll notice right now that these are thumbs down. They're not been approved yet because they haven't been QC'd. But you can show approved and you can show unapproved. Right now I've got these 6 features that are all unapproved. And I'm going to turn off the NHD just for a moment. So you can see the features. Click a row to zoom to the row.
Lamar.
Is that a question?
You're listening to it. Something at USGS.
Everyone, please mute unless you have a question. Thank you.
Okay, and also you can mouse over the row. If I zoom out a little bit, mouse over the row to highlight it. And make sure some of my stuff is visible here. Okay, so let's do a batch QC on these 6 lines here. My queues are closed up, and go down to lines, batch QC. This is the newest set of functions we have. I've already run some batch QC lines, but I'll start a new one. And I'm going to edit. You can edit an entire service. Be careful when you do that, because you're talking about batch QCing on a service might have very many thousands of events, I typically, almost always, will make a queue of a smaller number of features. The queue I'm going to run today is Wild and Scenic Rivers Beaumont. So I'm going to give this a name, Wild and Scenic Rivers Beaumont. And I'll start with something small today. My snap tolerance will be 10 meters. My QC tolerance will be 10 meters. And I'll do a 10 meter length percent change. What these mean. So if the start point or the end point of a line is within 10 meters of an NHD feature, it will snap. Both your start point and your end point of your line must be in tolerance. If one of them is in tolerance but the other is not, HydroAdd will not redraw the lines and won't do a network trace on the NHD. So if there's an NHD feature within 10 meters, it'll draw. My QC tolerance is 10 meters. So if a start point or an end point moves up to 10 meters, QC will approve it. If it moves, say 5 meters, it will still be approved. Usually when you, I'm going to be approving everything because I have a 10 meter snap tolerance and a 10 meter QC tolerance and the length change tolerance. This is a percentage. When you have a reach code, a very long one, and we have a lot of long ones in the Wild and Scenic Rivers, they're going to be split at the reach code. So the newly drawn features that are exactly coincident with the NHD are going to be smaller than the original. That percentage of length change is what we can QC on. So if something is very much shorter, like 90% shorter, then it won't be automatically approved. It'll still be thumbs down. Keep in mind that if the snap tolerance, if there's something in the snap tolerance within 10 meters, it's going to snap no matter what. But the length change is a great thing to QC on when you're doing lines. Let's just kick this job off. And you can watch the progress up here. Right now I've processed 0 of 0 and approved to 0. So I've just processed 3 of 6, 6 of 6, we're done. 19 is the resulting number of reach codes. So 6 inputs turned into 19 because they split at the reach codes. And right now none are published. Publishing is when you publish your results back to ArcGIS Online. The benefit of having a web-based tool is that the results here, I'll show you the results. Here's the queue, the batch QC queue. These results reside only on the HydroAdd servers, the application server. What I see here is a whole bunch of stuff that, well, this is not snapped. This one here, let me close this. This one was not snapped. Probably a start or maybe one of these lines. We can see why this is. We can take a look here. Let's turn the NHD back on for a sec. This feature here. So that looks to me like it's in tolerance. Well, it might be a little bit far. I don't know if it's farther away than 10 meters. Let's look at the other end. Let's see why that might. If I hold my mouse over it, it turns yellow so I can find it faster. There's the end. Oh yeah, so that's way out of tolerance. This is why. This point over here just is not within 10 meters. There's no way that's 10 meters. It's probably 100 meters. So that one didn't redraw because it wasn't within snap tolerance. But a lot of these other ones did. Like the original is here. It's snapped. But why was this not approved? It's probably because it's not a length change tolerance. Yeah, sure enough, it's not. You can get the details by clicking the details. And so the length percentage change of that little feature is 93% change. It got quite a bit smaller than the original. It's in snap tolerance. It's in QC tolerance, but it's not length change tolerance. An original reach code match. So batch QC honors the reach code if it's there. If you don't have a reach code, it'll use name if you have it. If you have both, name and reach code is prioritized. So I think we can get better results here by running this again with some different tolerances. So let's do that. Wild and Scenic Rivers V2, and let's give it a 50 meter snap tolerance, a 50 meter QC tolerance. And let's just go with the defaults. 50 meters for length change tolerance. Job appears, it'll run through those 6 features. And there's the complete. Now, see, you can see that we got better results because with the slightly bigger tolerance, my number of inputs went from 6 to 19, but with a better tolerance, I have now 83. So you change the tolerance just a little tiny bit, and there are more features in the buffer around your start and end points. So let's see how our results look here. So this one got cut into a bunch of pieces. Let's turn off NHD for a sec. Sometimes when you give a larger snap tolerance, there are more features available, but they're not necessarily the right features. So occasionally when you up your snap tolerance, you'll see that the resulting trace, sometimes goes off the rails. Like these are not correct. They're in snap tolerance, the start and end point, but the trace brings it down here. In the Wildland Scenic River original, you can see the original is in cyan and the new trace is in red. And then this one still didn't snap. That one piece down here that's 100 meters probably, but the rest of these all look pretty good. All these you see yeses all the way down in snap tolerance. In length change tolerance you see no's all the way down. We could probably improve our results even more by increasing our length percent change. So let's do that same cue one more time. Version 3. We'll give it a snap tolerance of 50, a QC tolerance of 50, and let's do our length change tolerance all the way up to 95%. There's our results. 5 or 6, wait for it. So same number of features, but I've got a better percentage, 31.3% approved. Whereas the last time I did it with a length change tolerance of 50, I had 0 approved. So let's see what that looks like in our queue. There's an approval there, so that's within a 95%. Let's take a look at that line. So here's zooming out a bit. This little guy is within 95% length change tolerance. It looks like it's in the right place. So I would approve that. So I would publish that. So you can publish individual lines that you like back to ArcGIS online. This looks good, so I'll just publish it. I'm writing my results back to ArcGIS Online. You see the icon, the cloud icon changed, and now it's got a check mark. It's been published. I've just written my result back to AGOL for just this one feature though. And let's see how we did down further here. So what I'm going to suggest for most users, once you've run a batch QC for lines, it helps to just publish the whole thing. That way you can have your published results have reach codes on them. They all have reach codes because they were all in snap tolerance. So the work of addressing is done. What we've got to do now is publish these back to ArcGIS Online. So I'm going to select all of them. So everything that's thumbs up and everything that's thumbs down alike is going to be published. So I'll just kick off a publishing job, and it says caution, lines QC jobs will overwrite your data in your service layer. This cannot be undone. Now, as GISers, I'll publish right now. As GISers, you know, your original data is still in your ArcGIS Pro project, and we all know we got to protect our original data at all costs. So while these guys are publishing, it'll take a few minutes to publish. That's what I was talking about as one of the limitations. So I can show you a little bit about points batch QC while that's doing its job. So I've run some point batch QC already. think I made a queue that I was gonna demo with. Yes, the North Atlantic Aquatic Conservation Collaboration. I have a queue. I selected this queue by HUC 05010002. So that's the HUC 8 I used to select. And I'll turn that WBD on. So just a handful of features up here in New York State. You can see these are the features in that HUC 8. So now that we have identified what we're going to be QCing, I will go to points batch QC and run that. The queue that we've chosen is NACC 05010002. And we'll just do the tolerance 50, just do the defaults of 50 and let it go. So this should probably go pretty quick. 13 features. And we're done. Let's take a look at our results. So this data is really, really tight. Let me turn on the NHD. You can see what's going on here. Really close to the flow lines already. So these didn't move very far at all. I'm looking for one that has a yellow line that indicates the snap distance. There's one. But look how blurry the US topo is. Like, it's really zoomed in. And we can get details on how far the snapped. 1.9 meters. It's in snap tolerance and QC tolerance. Original reach code doesn't match because the data didn't have original reach codes. So a word about that. When you're doing batch QCs, it really helps if you already have a reach code. This is what migration is all about. If you have data that you've addressed before, you have that reach code, you'd run the batch QC. If the reach code is there in your data, HydroAdd will honor it. If you don't have a reach code, if you have a name, it'll honor the name too. If you have nothing, it's gonna snap to the closest thing that it finds. You'll get much better results if you have a reach code already. You know, if you just have a new data set and you've never addressed it before, you don't have a reach code or you don't have a name, you just have to power through, and it'll go easier next time because you'll have done the work of addressing. So when the NHD is updated, then you'll be able to address more quickly because you've already got those reach codes. Let's see how our lines batch QC is publishing. Okay, 83 out of 83 were published. So if we go back to our original queue, remember we had 6 features in our original queue? Go to WSR Beaumont, and our new queue is going to have, well, it's the same queue, but it's going to have more features. It should have 83, and there they are. We started with 6. And notice some of these are thumbs up and some are still thumbs down. That's the benefit of publishing everything all at once, because some are thumbs up and some are thumbs down. Like this guy here, this is weird. So this particular feature that I'm mousing over is yellow. That looks like a vestige that should not be there, so I'm just going to delete it. Okay, I'm going to also turn on one other service layer, and then my demo will be close to complete. 1 or 2, turn on this one. Oh, it's already on. Okay, so there were a couple spots that I mentioned to you where the batch QC process sort of went off the rails, and the way that trace network works is it pretty much looks for the shortest path. And so the results here follow the shortest network on the NHD, but that's not what the user wants, because the original data was out here somewhere in orange. So I actually, this morning before the demo, redrew where they're supposed to be. And so this is what you would do during editing. You would look for areas where it's just not the right network and delete those features that are on the wrong network and then redraw them on the correct one. Maybe we can show that really quick on a different one. Okay, let's see if we can do a quick demo on redrawing. I'll turn off HydroAdd line. So this is 3.00135.007. So what I'll do is I'm going to make a new line. Choose the surface layer that I'm drawing on. That was our test. And I'm going to turn on use full reach so that I'm drawing reach codes from measure 0 to measure 100 with just one click. And let's turn on HD too. I think ArcGIS Online is slowing down a little bit here for me. Yeah. Okay. Apologies for the slowdown. Okay. Might have to here. Might have to bail on this demo because I have a network slowdown here. Now let's try it here. If I could just show you how we can use full reach. Okay, let's try this. That worked nicely. I have a nice, and what was that number? 300135. I'm using the same source ID that was already present, .007. And we also make sure that we have the right feature type as prescribed by Wild and Scenic Rivers. Recreational. Save it. So there's you can see the feature there now. And I'll try to get one more in here. Same deal, useful reach. Nice, okay. Seven. It's recreational. Ah. Okay, so we just created the replacement. And what we can do is take out the, go up to search, take out the stuff that's not supposed to be there. Make sure we choose the right surface layer. And I'm going to draw an extent. I'm going to select those offending features. And remove them. Select them all at once and delete. So that was a fast little editing job where we took out the false trace, or it was a good trace, but it's just not the trace we wanted, and replaced it. Okay, how's my time here, Drew? It's 11:42.
Yeah.
This is a good spot for questions.
Okay. Okay, yeah, any questions? Any questions on the demo? not. I've got one.
Go right ahead.
Mike, you earlier in the same area here in Beaumont, you had showed some lines that it was grabbing that did seem far away from the main reach. You know, the endpoints is line, they were shown in red, right? They went a long way from the
Yeah.
from the reach you wanted. That's sort of what you just showed here, right? It's yes, the endpoints were fine. It's
Same exact deal. Yep.
Okay, but you didn't want the, you know, how the other segment is totally removed from the you know, the original intent. Okay.
Yeah.
Thanks.
Here's that result. The original is always in cyan. I borrowed these colors from Esri, and the new result is in red. And then you can mouse over to get the yellow results. I redrew those this morning just to see how it went, and I just used full reach. There was quite a few in there. One thing that HydroAdd does not yet have a requirement in my requirements document, but has not yet been implemented, is the ability to block certain reaches. And so I'm looking for a barrier, and I'm looking for a flag. Those of you that are familiar with those tools, the trace network tools in ArcMap. So I should be able to block a network. For example, if I see this happening in my results, I could run this again, just put a block here and a block here, a barrier down here, so that the trace doesn't go on the undesirable network. So that hopefully that'll come along this year, that requirement.
Okay, yeah, thanks. That's great to know.
Any questions in the chat?
Nothing in the chat for question. Any other call for questions while we're here? Roger's got a comment on having some data for you to test soon. I'm not sure what kind of data that is, Roger. But
Oh, sounds good, Roger. Looking forward to seeing it.
We're looking at culvert data in particular, and the NAC and the SARP are fish passage groups, and they are very interested in culverts. So we're looking for interchange of data to share culvert information.
Is that going to be point data or line?
I think you'll see some of both, depending on the state.
Sounds good.
thank you. And Curtis had a question on what technology is under this.
What technology is under this? A lot of the code is React. And we also use JSONs to deliver those, deliver the geometry to the API, the web API.
And have a question too from Ricardo asking, anything to say about the transition to 3D HP?
It's coming.
I don't know if that.
So what the development that you're looking at here is probably the last significant development for HydroAdd on NHD. And our development team will be shifting, outside of bugs and a few straggler requirements, the addressing team will be shifting development for addressing tools for 3D HP. Many of you probably heard that Dave Blodgett talk last month about main stems. That will be the basis for addressing in 3D HP. Main stems are a little different than reach code. Reach codes have given us some challenges with our reach code maintenance table. Main stems will be a really neat way to the main stems data set will be sort of an amalgamation of many different like codified, like, everyone knows what the Mississippi River is, and so it's the same in the medium res as it is in the high res. It's roughly in the same spots, so we can turn that well established or well known linear feature into a main stem, and that's what we'll be addressing too. Measures will probably be less important than just identifying the main stem and using an XY. That's probably where we're going to go. But I can't make any promises because we don't. It's not in place yet. We're starting the research this year. That's a good question. Thank you.
Okay, yeah. Speaking of questions, a couple more here.
Okay.
From Mark Weber, will addressing continue addressing to NHT plus HR when transitioning to 3D HP or strictly address to 3D HP?
So it'll probably be 3D HP and NHD high res. Right now, what you're looking at is NHD high res only, and that's what this tool is designed to do, is only on the high res. It's essentially a migration tool. So if you have medium res data and it's already got reach codes, then you can migrate those with HydroAdd. In the future, you'll be able to migrate reach codes to main stems. That's my thinking. I don't think we're going to be keeping I don't think we're going to look backwards to addressing to the medium res. Future iterations of HydroAdd should be able to address to 3HP and maybe high res too, maybe.
Okay, thank you.
Did I answer the question that Mark was after?
Yep, it does. And okay. Thank you for that. And Curtis had added a little link on the React.
Oh, very good.
Component-based open source JavaScript library for building user interfaces. So thank you, Curtis. And any other questions while we're here on the demo? I presume, Mike, we could also take questions on the content of the presentation too.
Oh, certainly. Let me put my last remaining slide up there.
Okay, and Greg Cox is saying 3DHP will have a load of NHD geometries at the get-go. Yeah, speaking of reach codes. And
oh, yeah.
We had.
So here, if you have further questions that you want to hit me up offline, that's fine. You can email to hydroadd@usgs.gov or nhd@usgs.gov. All these will get to me eventually. But hydroadd.usgs, yeah.
So without any further ado, thank you all very much for coming today. Any final questions or comments? And if not, we'll see you hopefully next month. We hold the calls on the fourth Tuesday of the month, so that means our next call would theoretically be April 25th at 1 p.m. Eastern Time. Thank you all very much. Okay, bye-bye.